A very good evening to all corporate members of IEI. It's a happy moment to have you all for this 110th webinar, a weekly online lecture series being organized by IEI Salem Local Center, a weekly exchange of ideas, engineers talk in connection with the celebration of Energy Conservation Week. I request the chairman of IEI Salem Local Center to welcome the guests and the gathering. Please, sir.
Thank you, sir. So, very good evening to all again. So, the eve of Engineer Energy Conservation Week 2025, organized jointly by NRIT, Renewable Energy Private Limited, and the Institute of Engineers Salem Local Center. So, we are very happy to welcome today's eminent guest speaker, Dr. Professor S. Batma, for delivering the energy audit. So it's a very important topic. Even the practicing engineers must know about this subject, as well as the academician and budding engineers, electrical engineers. So I'm happy to welcome Dr. S. Batma, madam, who has more than 33 years of experience in the electrical electronics field, both as an academician and also she is a renowned energy auditor. I think she is one of the first generation energy auditor in our region. Welcome, madam.
Thank you, sir. Thank you.
Welcome, madam. Thank you for sparing your valuable time. And also, I think most of the members from department also joined for eagerly waiting your lecture.
Sure, sir. Thank you, sir.
Thank you, madam. So I thank our past chairman, immediate past chairman, Dr. Tangaraj, and one of the energy engineers talk team for arranging this important topic, energy audit, from the eminent professor. Thank you, sir. So we welcome all the committee members and also the honorary secretary Sadish sir and senior members who have joined this important topic on the eve of Engineers Talk, as well as the Energy Conservation Week. So both we are linking. So once again, I welcome you all for the wonderful evening, and I once again welcome today's chief guest, Professor Dr. S. Batma, for delivering the topic on the energy audit. Okay, thank you all. Thank you.
Thank you, sir. Thank you very much. And now it's my pleasure to introduce the chief guest and the keynote speaker of today's program, Dr. S. Batma, ME PhD, Certified Energy Auditor, Professor, Department of Electrical and Electronics Engineering, Sona College of Technology, Salem. She is a postgraduate and doctorate in electrical engineering. She has got nearly 33 years of work experience, and her research areas of interest is energy conservation and auditing, which is the topic of today. And he is doing consultative works related to energy audit. She holds a membership in various professional bodies like IEEE, ISTE, IEI, ISSE, and BEE certified energy auditor. She has received many awards. To name a few, she has received AICTE's Leelavati Award in the year 2020 on the theme Women Entrepreneurship by presenting a unique intervention carried out under the overall theme Women Empowerment. She has also received ISTE's Periyar Award for the Best Engineering College Teacher in the year 2019. She has also received a Best Women Engineer Award from IEI Salem Local Center in the year 2014. She has presented nearly 35 special lectures, and she has contributed for the establishment of the new laboratories and centers of excellence in the Department of Electrical Engineering in the college, Sona College of Technology. She has also coordinated the department for getting NBA accreditation in the Tier 1 cycle and cycle 2. And she has been the chairman for strategic planning group in the department. She has also acted as college level coordinator for AICTE, CAA awards and NIRF. She has also been a student branch counselor of Sona College of Technology for IEEE, and she has conducted many programs through IEEE for students actively. And she is the chairman board of studies of autonomous board in Sona College of Technology. And she has been guiding PhD scholars of Anna University, Chennai for over nearly 10 years. And she has published 6 books, and she has presented in 42 international publications. She has also presented 33 papers in national and international conferences. With these words of introduction, I would like to invite Dr. Padma to present on the topic energy audit. Over to Dr. Padma, ma'am. Please, ma'am.
Thank you, sir. Very good evening to one and all present here. So I am very thankful to the chairman of IEI Salem Local Center, Engineer Loganathan, and Honorary Secretary Dr. Satish Kumar. And also I am very much thankful to the engineer staff team, and especially Dr. Tangaraj, who has contacted me. And I thank all the participants who have joined here for listening my lecture. So last year also I have given the same lecture, but this time I have added a few portions which will be of the recent trend. Shall we go to the topic? So especially the energy is the trending word, buzzword we can say. And so for any economic development of our country, energy is very, very important, because day to day our demand is increasing, and the global energy need is growing between 11 to 18% by 2020. And we are also adding low carbon energy sources, that is renewable energy sources. And from UN, they have initialized that 65 to 80% of global power generation should be from this renewable energies sources by 2050. So that is why this energy sector is of a very important sector, and many upcoming innovations and renewable energy additions, everything is happening. And so UN has formulated the Sustainable Development Goal, and in that goal number 7 is affordable and clean energy. And according to this goal, so we have to ensure that everyone in the world has access to affordable, reliable, sustainable, and modern energy. So in that way, we are moving forward, and India has set some targets for goal number 7 according to SDG. And so we need access to electricity for each and everyone, and this has been implemented through Saubhagya scheme, and 100% this has been successful. This is successful. We have completed that goal. And then the second one is clean cooking fuel. So we have so many schemes available for that, especially for women, and ensure that 96.35% of households have access to clean cooking fuel as of now. And coming to the renewable energy, so we have to share the renewable energy by 40% by the year 2030. So that is our target. But 5 years ahead, we have completed that, and we are almost 51%. We have crossed the 50% limit. And emission intensity is so to reduce the emission intensity, that is the carbon greenhouse gas emission. So to to 33 to 35% by the year 2030. So before going to energy audit, so let us have some few insights about the Indian national level power status. So as on October 2025, so we have installed power capacity of 505 gigawatts. That is 5 lakh megawatt of installed power we have. And a major milestone was achieved by meeting its COP26. So COP26 is nothing but UN's climate change conference. And so goal of having 50% non-fossil fuels capacity by 2030. So as I have told, we have achieved that. And so we can see the non-renewable energy like coal and oil, gas. So all those things contribute to 49% of our installed capacity. And the remaining 260 gigawatts, 260 is from the renewable and non-fossil fuels. It is around 51%. And coming to Tamil Nadu, we are also leading in renewable energy sources, and we have installed capacity of 17 gigawatts from non-renewable, and from renewable we have around 23 to 25 gigawatts, and still we are adding to that renewable energy sources. So we will see why we have seen this energy status of India and Tamil Nadu in the later part of my slides. And coming to energy management, it is nothing but the judicial and effective use of energy. So to maximize profits, and so maximize profits in the sense we have to minimize the cost and enhance the competitive positions. We should not also sacrifice in quality. So the objectives of this energy management are we have to achieve and maintain optimum energy procurement and utilization throughout the organization, whether it is industry or whatever it is. We should have throughout our organization, whether it is an office or industry line, whatever it is, we have to maintain optimum energy procurement and utilization, and to minimize energy cost and also waste without affecting production and quality, and to minimize environmental effects. These are the three main objectives for going towards energy management and energy audit. And so energy management is we have to manage, and how we are going to manage is through energy audit. So the energy audit is the key to a systematic approach for decision making in the area of energy management, and it balances the total energy input with its use and serves to identify all the energy streams in a facility. So what are all the ways the energy is spent? All those things can be obtained through this energy audit. So it is nothing but the verification, monitoring, and analysis of use of energy, including the submission of technical report containing recommendations for improving energy efficiency with cost benefit analysis and an action plan to reduce the energy consumption. All these put together is called as energy audit. So in energy audit, we are going to monitor, we are going to analyze wherever the energy is spent and how we can reduce, and what are all the discrepancies where the energy is wasted, why it is wasted. All those analysis will be done, and how we are going to improve the efficiency we are going to concentrate, and that improvement in energy efficiency is done with cost benefit analysis. So all those things we can see in the later slides. What is the need for energy audit? We all know in any industry the top expenses are mainly in energy, labor, and materials. So in all of the three, so we are going to concentrate on energy, where there are more scope for reducing the expenses, operating expenses. If one were to relate the manageability of cost savings in each of the above component, energy would invariably emerge as the top ranker. Of course, for labor and all, there are so many automation and materials also. We are going for top class material, A1 material, like that we are going for. So out of these three, the energy plays a vital role in saving the cost of the operating cost. The energy audit helps to understand more about the ways of energy and fuels are used in any industry, and help in identifying the areas where waste can occur and where there is scope for improvements. So it would give a positive orientation towards the energy cost reduction. So not only the cost reduction, so we will be seeing, so since we are analyzing, since we are monitoring, we could understand wherever the operating machines may become failure, or where we have to go for maintenance, all those things. The preventive maintenance can happen with this energy audit, and we can also have some quality control programs. All these three can happen with energy audit. So to determine ways to reduce energy consumption per unit of product output or lower operating costs is the main objective of energy audit, and it provides a benchmark reference point, so we can reduce the energy but not beyond an extent. So that reference level has to be fixed so that we can reach towards that energy level. So tangible benefits, intangible benefits, all those things we have discussed as so the reduction in energy consumption, better control over quality. So the raw material savings consumption can be saved, and the life of the equipment, as I've told, preventive maintenance. So the life of the equipment can be better, and we are going to reduce greenhouse gas emissions. And intangible benefits are plant expansion, energy efficient equipment purchase, alternate fuel energy sources or source options, identification and feasible recommendations for critical issues. So for going towards energy audit, before to that, so in energy management, so we have to have some planning steps. So there are four important pillars for successful energy management. So technical ability we should have, monitoring system should be available, and strategic plan should be available, and above all, the top management support should be available. Without the top management support, we could not execute any of these three energy management part. And so it is a cyclic level. So initially assessing the energy profile and establishing baseline. Once the reference point is fixed and energy policy planning, everything is done. So we have to go for implementation. And again, we have to evaluate the energy performance. And so we should recognize the achievements, and it is a cyclic process. Again, we have to go for, so step by step improvement in energy conservation should happen. And this should be the structure in any of the industries. A factory manager should be there, an energy manager should be there, and production manager, finance manager. Everything plays a major role in any energy cell. So coming to the types of energy audit, so the type of energy audit to be performed depends on the three categories, that is function and type of the industry, which industry we are going to do an audit, whether it is IT industry or steel industry or paper industry, whatever it is, it depends on the industry. So each industry is having different types of equipment available. Accordingly, the energy audit should be performed, and depth to which the final audit is needed, whether a little bit of audit is enough or in-depth audit is needed, all those things should be finalized, and potential and magnitude of cost reduction desired. So we should have a benchmark, this much energy bill has to be reduced. Accordingly, we have to go for the audit. All these three things decide the type of energy audit. Accordingly, this can be classified into preliminary audit, targeted audit, and detailed audit. Preliminary audit is nothing but just a walkthrough audit. So just we can see the environment, and we can say what are all the things we can do to reduce the energy bill. And targeted audit in the sense, so maybe some part of the production line or some of the equipment, we may feel, the operators may feel that that particular equipment is not doing good, the efficiency is not good. So such inputs may be obtained from the operators, and we should focus only on that particular production line or for particular area. So that is called as targeted audit. And detailed audit in the sense, for the entire unit, for entire industry, we have to do the audit. We have to analyze all the production lines or streams, the lighting, everything we should take care. And wherever possible, we should give the suggestions for improvement in the energy consumption. And the energy audit team should collect the following baseline data. So before going into the energy audit, we should have some baseline data so that we can work out on that. So the technology, what are all the processes used in that particular industry, and what are all the equipment available, what is the rating of the equipment, what is the capacity, how it is utilized, and what is the input materials, how it is used, what is the water consumption, fuel consumption, electrical energy consumption, steam consumption. If suppose some industry require steam related operations, and other inputs such as compressed air, cooling water, all those details should be collected. These are all the baseline data upon which the energy auditor should work and should do the audit. And in the detailed audit, so energy consumption by type of energy, by department, by major items of process equipment, all those things should be collected during the detailed audit. So that is the baseline data. Based on that, we should go and analyze. And in the detailed audit, these things should be recorded. And material balance data. So what is the raw material, and what is the intermediate material which we are getting, what is the final product, all those things. Once the raw material comes, how it is the energy is utilized in various verticals, and what are all the recycled material used, or how the waste from the industry is used as recycled material in other industries or in other processes, all those things, use of scrap, waste products, production of byproducts. So which are all the things which can be used, reused, etc. All those things we should study during the audit. And energy cost and tariff data should be obtained, and process and material flow diagrams should be drawn. And then generation and distribution of site services like compressed air, steam, everything. And the sources of energy supply, whether it is from grid or whether any cogeneration plant is available, or any wind generation or solar generation is available, whether we are purchasing somewhere and we are using that here, all those things should be obtained during the detailed audit. And potential for fuel substitution, process modifications, and the use of cogeneration systems, and energy management procedures, and energy awareness training programs within the establishments, all those things should be done. And for doing energy audit, the important instruments which we are going to use will be the power analyzer, flue gas analyzer, high pressure meter, anemometer, temperature indicator. So that should be sensor based, and lux meter for measuring the lighting level, and pilot tubes, infrared thermometers, and ultrasonic flow meters, load manager, harmonic analyzer, hygrometer, air compressor, flow meter. All those things are required for doing energy audit. All these will not be used in all the industries. It depends upon the industry, and it depends upon the audit which we are going to do, for which process we are going to do. So mainly the power analyzer and thermal analyzer and thermometers will do for many industries. And rarely the other industries, mainly the steel industries, we will be using flue gas analyzer and all. So in hotels, they may be requiring lux level, and the compressor for compressor, flow meters may be required. So it depends upon the industry for which we are going to do the audit. And scope of the energy audit. So it depends mainly on air compressors. We may do audit. So the energy audit may be done in three ways. One is thermal audit, mechanical audit, or electrical audit. So then thermal comes under mechanical. So mainly the mechanical and electrical. And whenever we do water audit, some civil work will be there. And we will be doing the audits in air compressors, and assembly lines, boilers, steam systems, AHU, chilled water systems, cooling water systems, pumps, motors, distribution systems. We will be studying about harmonics and power factor improvement, cabling. In cables and also, we can check for the temperatures, and how the cable joint is done, whether there is any loose connection. In those places, you may expect abnormal temperature conditions, which may be dangerous, and fire may occur due to those things. So in those cases, we can use thermal analyzer. So lighting, fans and blowers, heaters, all those things we can do energy audit. Mainly these will be the main scope for the energy audit. So wherever these equipment are available, so definitely we should go for the audits. And last time when I was taking at the last minute, I have introduced about our Sona Energy Audit team. So now in between, I thought of telling you this. So I am doing energy audit under with a team. So my team members are Dr. Karthikeyan, Dr. Panneerselvam, and Dr. Kalaivanan. So with these three people and myself, we are doing energy audit. Some of the non-teaching staff also will be utilizing during audit purposes. And in our campus, so we have energy analyzer, class A analyzer we are having, and flue gas analyzer, and thermal imager is available, lux meter we are having, and these lux meters are also recordable one. All the equipment whichever we are using is we can record, and then after coming to our place, we can download the data and we can analyze. And sectors, so other equipment whenever needed, we can purchase it, or for 1 day or 2 days we can hire and we can do the audit. And the sectors where energy audit has been done by Sona, our team members are in railway, solar power plants, and so we have done audits almost in all the sectors, and throughout the country we have done. So we have gone to Noida also for doing audit, and this side, Kerala, Karnataka, Hyderabad, Andhra, all those places we have done audit. And they're all our clients. So these are the pictures where they have done energy audit. And coming to the methodology, so we have a three-pronged approach. So we have to analyze capacity utilization, and then technology upgradation, fine-tuning. All these three things will be done in our audit. And outcome of the energy audit report will be based on the input, we will be giving the output. So the overall picture of the plant energy use, how they have used, and summary of energy cost distributions, preliminary assessments and comparisons, areas of energy efficiency improvement, and energy cost reduction potential. All those things will be given by after final audit report. In audit report, we can find all these things. And so mainly we will do the worksheet for economic feasibility. So there are three things. One is the capex cost and the opex cost and annual savings. These are the three things. So the investment will be under that capex heading. We may think of equipment, civil work, instrumentation, auxiliaries. All those costs will be coming under investment cost. And operating cost will be cost of the capital, maintenance, manpower, energy depreciation. All those things will come under operating cost. And the savings will be in thermal energy saving, electrical energy saving. We can go for raw material saving or waste disposal. In all these four areas, we can see for annual savings. And net saving per year will be annual savings minus the annual operating cost. And we can from that we can calculate the simple payback period. And so in classifying the energy conservation measures, we can categorize into three headings. One is low cost. By investing low cost, we may expect high returns. That is the first category, which is very much possible for implementation. And then the medium cost and medium return, the second level of implementation, and high cost and high return, that is third level of implementation. And also based on those things, we should give the project priority guideline. So priority guideline we should see for the economic feasibility, technical feasibility, and risk feasibility, all those things we can prioritize, and we can go for implementation. So in the if the priority level is A, it is good. So the economical feasibility is well defined and attractive, and in the existing technology is adequate and no risk or it is highly feasible. And the second category is maybe, so it is well defined and only marginally acceptable in the economic sense. And in the technical feasibility, existing methodology may be updated, or new equipment may be purchased, or lack of confirmation. All those things comes under technical feasibility. And minor operating risk, and we may think over, we can go for implementation. And the C is we should hold. So poorly defined and marginally acceptable. So that is economic feasibility is very poor. Economically, it is less viable, and existing technology is inadequate. We may have to invest major new purchase of equipment, of high cost equipment, all those things. And the risk is it is doubtful, and we should hold and we should analyze, and then finally we have to decide. And D category, we should not go for implementation. So the economic feasibility will not be there. So technical feasibility, it needs major breakthrough, not feasible. So this example I have discussed in my last topic of my last portion of my slide. Why the major breakthrough has come now. And this is the summary. So this is what we will be giving. And the energy saving, so of course the cost part we will not be concentrating much. So by seeing that, we can give some recommendations, the energy saving recommendation. And so these can be calculated by the people, those who are in the industry. And so types and priority of energy saving. So we can give like this. One is no investment. So the operational, just the operational improvement, the housekeeping, all those things. So for example, if we are shifting the few of the operations during off-peak period. So in peak period, the electricity charges are high compared to the off-peak period. So few of the operations may be shifted to off-peak period, so that is without any investment we are doing that. So that is no investment saving opportunity that can be taken up first. And low investment, so slight modifications in the in the equipment or control part, or any process change. Prioritize the flow, or from all those things we may require very low investment, and that may give huge annual savings. That can be taken as category B. And high investment, that is long term. So if suppose we are installing solar power plant, so it may take some 5 to 6 years for getting the investment. So that is high investment, long term. So the energy efficient devices, product modifications, technology change, so all those things will be coming under high investment long term plan. So we should see the payback period, and if it is feasible, and we can go for it. So this is the case study which we have done. Sir Tangraj sir, still can I extend for 10 minutes?
Okay, ma'am.
Okay, because we have started more around 7:15, more 7:15 and above, I think. So we could not complete before the time. So I'll try to complete in 5 minutes. So in the case study, we went for a theme park, and we have done a walkthrough audit. And on seeing those things, we have given some 20 suggestions. Only 12 suggestions I have recorded here. And by observing these things, we have informed them, and whatever possible they have done it. And after that, they have the energy cost of the theme park has reduced, and they have requested for detailed audit, and we have completed that also. And in an IT industry, so first we will see, so whenever we go, we will study the electrical flow line. So what are all the, so here they were having 100 kilowatt solar plant, HT powerhouse was there. and LT powerhouse, and it has been divided into four lines as Studio 1, 2, 3, and 4. And it is the energy consumption. So we will collect the data from them, the EB bills and everything we will collect, and we will do a chart, and based on that we can obtain the which how many units they have paid for peak hour, and what is the load during off peak hour. So all those things we will observe. And so wherever we think that that particular line has to be given an importance for audit, so we will go and do it. And so this is one of the top three are from the energy analyzer. We have seen the harmonics, and we have seen the current THT and voltage THT, power factor, all those things we have studied. And the bottom two are from thermal imager pictures. And this is the picture. So this is the AHU pipeline. Insulation is failed, and when the insulation is failed, we can see that the temperature is very much high. So we can see that part alone in the thermal imager, and all the temperature values will also be given, and based on that we will give our recommendations. And so we have, after doing audit, we have categorized into A, B, and C category. So A has to be very much important, urgent, and which needs very immediate action. And B can be done in 1 or 2 months, and C may be completed based on the availability of funds. So we have given two suggestions. One is category A and category B. And then so the thermography observations and recommendations in many panels we have taken, and in many of the places it was not good. And we have so solar incomer line, solar Studio 3 AC incoming line. So AC rooms in all those places, the connections were not good, and the temperatures were very high. So we can see 61 degrees, 44 degrees, 35.9 degrees, all those things we have recorded when we have informed them. And this is the power analyzer observation and recommendations we have given. And so the technology breakthrough I have told in the previous cases. The technology breakthrough we can see in battery energy storage systems. Normally, the storage system was not adopted because of the cost investment, and now the government of India as well as government of Tamil Nadu, they are taking steps for implementing the energy storage systems, especially the battery energy storage systems. Already this has been implemented in Delhi, Maharashtra, Assam, and all. So now recently this has come to Tamil Nadu government also. The TNEB is also doing the same thing. They have done the survey report. They have analyzed the peak demand, and they have projected for the years up to 28, 29. So the year-on-year growth has been given, and based on the demand, peak demands. So only for peak demand shaving purposes, they are going for energy storage systems. And the following percentages of total energy consumed are mandated to be sourced from renewable energy, either directly or through storage mechanisms. So through storage mechanisms, they have given, so the 2%, 2.5 year on year, the percentage of storage requirement is increasing, and it is nothing. It is around 5,500 units. So this year it has been projected as 7,767 megawatt hour per day. So this is the requirement. This is only for the peak hours. So they have not done analysis for the entire day. Only for the peak period, how much energy storage or solar energy or wind energy, whatever it is, can be obtained. That is calculate. That is through survey they have projected, and based on that they are working. And recently they are about to go for battery energy storage systems in 7 locations in Tamil Nadu. And so I have done one calculation for energy saving opportunity with the battery energy storage system. So I have taken an IT industry where it is having 500 kilowatt rooftop, And the proposed battery energy storage system is 500 kilowatts, 1000 kilowatt hour. And the project life, that is battery life, we have taken about 15 years, and the efficiency of the battery is 90%. And as per Tamil Nadu tariff assumptions for IT industry, HT tariff, so it is almost around. So it is now, it is slightly higher, 7 rupees per kilowatt hour, and the peak charges are 2.5 rupees per kilowatt hour per unit it is. And demand charges, it is of course 450 per kVA per month. And solar export value, we all know, if suppose they have already installed a solar with a capacity of 500 kilowatt, but whenever it is excess for their utilization, it will be exported to the grid. The export charges are given as just 3 rupees per unit. So now it is still it is low, it is around 2.25, something like that. And the DG generation cost is so 1 liter of DG gives only around 3.5 to 4 units. And so it is around 22 to 25 rupees per unit when we are using DG. And so before BESS, we have identified during audit, we could foresee the audit issues are as solar utilization limited to daytime, and few and the whatever the utilized by the industry, the remaining is exported to the grid at a low cost. And high evening night peak demand. So during night time and all, so the demand is increased, and a significant DC usage during outages. Whenever the EV supply is not available, they have to go for DG, and the DG cost is very high, around 25 rupees per unit. And the penalties during peak hours and reliability requirement, all those things matter during audit, because in when it comes to production industries, 24/7 power is required. So if suppose there is no EV supply, they have to run with DG. So that is the case. And so with the battery energy storage systems, so during daytime, excess solar is charged to storage battery, and evening peak hours, so the battery, the stored energy from the battery can be used. And during night time also, the base load can be used through the battery. And out through whenever there is outage, we need not go with the DG, and instant backup is available with the battery energy storage system. And so annual savings has been calculated as solar energy shifting. So if suppose we are exporting it, we will be getting only 3 rupees. Whenever we are using by ourselves after during peak time or during off peak time, whatever, during night time, whatever it is, so we can save 4 rupees per unit, and annual benefit it comes around 24 lakhs. And demand charge reduction, so whenever we have backup with battery, so the maximum demand which we have requested can be reduced. So say for example 200 kVA is reduced. So in that we can reduce we can get an annual benefit of 10.8 lakhs. And DG and fuel costs, through that we can have 27 lakhs of cost benefit. And penalty, with the penalty, so whenever we are using EV supply during peak period, we have to pay some amount, excess amount per unit, and that can be saved. And that comes around 7.5 lakhs annually. And total annual savings is around 70 lakhs. And so the project cost and O&M cost, so we can see net annual benefit as 65 lakhs. And so the simple payback period of 7 to 8 years with IRR of 15%, all these things we can get. So many benefits we can get it with the battery energy storage system. So which is recently the upcoming technology. So with these, many of the industries are now thinking of going with battery energy storage systems. And in future, such technology improvement, this is the technology breakthrough, I can say. even in the parliament last week, they have discussed that through battery energy storage, the unit cost has come down to 2 rupees 1 paise, 2.1 rupees 2.1. But in Tamil Nadu, they are getting around 2.46 per unit, rupees 2.46 per unit. So still it is reducing. Whenever there is in future, the cost of battery, everything will go down, and the per unit cost will also decrease. And we need not go for additional. Whenever the peak period is available, the generation has to be done through either if suppose it is evening time, we cannot expect renewable energy. That is solar, we cannot expect. Of course, wind may be available, and we should go for thermal or some other fossil fuel based energy generation. So that 1 unit of generation costs many installation of energy, fossil based energy generation plants will be very much higher. So instead of that, we can go for battery energy storage system. And the government is also giving subsidy for installation of battery energy storage systems in substations. So for each megawatt hour, they are giving 18 lakhs per megawatt hour the installer is getting. So in future, that will be the trend. And so I thought of giving that input to you. So instead of going for installation of new generating plants, we can go for battery energy storage systems. So during off-peak period, we can store the energy, and during off-peak period, we can during peak period, we can utilize whatever the energy is stored in the battery that can be utilized, which will, uh, as I have given the table, that will give many benefits, cost benefits we can get. So with this, I wish to conclude. So energy is life. So let us all join together in conserving the energy. Thank you all. So I thought of giving you some more input in net zero. So if some opportunity is given in next year, I will talk about net zero buildings. Uh, Let us think about it. Thank you.
Thank you, madam. And in case if participants have some queries, please ask. Participants, if you have any queries, you can raise your queries.
Good evening, madam.
Good evening,
Your
ma'am.
section is so informative. How the cost effective is to be often reduced by after the energy audit. It's also very latest technology with the battery energy storage system. So after the battery energy storage system installation, the 1 unit cost, how much to reduce the 1 unit cost, how much initial cost will be invested, madam?
That is what I have told, madam. So it takes around 5 to 8 years for getting the payback. Payback period is around 5 to 8 years. So installation cost will be very much high. That is the main
Okay.
drawback.
Oh, installation cost is very high, but running cost, ma'am?
Running cost we can accommodate. No issues on that. But initial
Okay.
installation cost will be very high.
Okay. Okay. Thank you, ma'am.
Thank you, madam.
Any further queries from participants? Okay. Okay, thank you, ma'am. Thank you very much for your
Thank you, sir.
insightful
Thank you, sir.
presentation on
Thank you, sir.
energy
Thank you.
audit. Thank you. And now I would
Thank
like
you,
to invite Dr. K. Tangaraj, immediate past chairman of IEI Salem Local Center, to propose vote of thanks. Please, sir.
Sir, thank you, sir.
Sir, Thangaraj sir, your voice is not audible.
Sir, am I audible, sir? Sir, am I
Now it
audible,
is
sir?
audible. Yeah, yeah. Now
Sir,
it
am I
is
audible?
audible. Yeah, yeah.
Okay, sir. Thank you, sir.
Sir, why you have muted your mic? Thangaraj sir?
Sir, my phone network issue, sir. So I am joining another phone.
Well.
Sir, Arun, sir, thank you, sir. Yeah, very good evening to one and all present for this today's program. On behalf of the Institution of Engineers India, Salem Local Center, it is my privilege and honor to propose the vote of thanks for our 110th special webinar under the Engineers Talk series, celebrating as part of Engineering Energy Conservation Week. First and foremost, I extend my heartfelt gratitude to our today's chief guest and keynote speaker, Dr. S. Batma ma'am, Head of Department of Electrical and Electronics Engineering, Sonakalju Technology, Salem, for sparing her valuable time and delivering an enlightening lecture on energy audit. Ma'am, your session has brought deep insights, practical understanding, and a tremendous awareness on the importance of energy efficiency and conservation. We are truly enriched by your knowledge, ma'am. Thank you, ma'am. We are thank NERT Renewable Energy Private Limited Salem for sponsoring our Energy Conservation Week and supporting the noble cause of energy conservation. I also express my sincere thanks to our respected chairman, Engineer S. Loganathan sir, and Honorary Secretary Dr. R. Satish Kumar sir for their continuous encouragement, leadership, and guidance in successfully organizing this weekly knowledge sharing platform. A special word of appreciation to our organizing team, which again includes Dr. Kumurvel sir, Dr. Damani ma'am, Engineer Senthil Kumar sir, Engineer Armugam sir, Engineer Ainar sir, and also the faculty again members from Electrical Department of Sonakalju Technology, our IEI office staff, Engineer T. Thiagu, volunteers whose effort ensuring the smooth conduct of today's webinar. We are extremely thankful to all the corporate members, IEA members, faculty, students, professionals, and participants who have joined us today from various locations. Your consistent participation is our motivation, and we look forward to seeing you again in forthcoming Engineers Talk session also. As we conclude this wonderful evening, let us continue to uphold the spirit of learning and contribute towards energy conservation for a better, sustainable tomorrow. Thank you all once again. Have a great evening. Stay safe. Stay inspired. Thank you, sir. Jai Hind.
Thank you.
Thank you, sir. Thank you very much.